All right, I'm going to go on mute here for a bit, and I think we should be good to go. The poll questions have been entered.
Okay. Did you want to set me up as an organizer so I can watch the questions?
I'll put you both as organizers. That's interesting because I did that yesterday. Here's the thing, a question for you, Ben. We had we set you both up as panelists, and you were not able to use that link to come back in for the practice yesterday. So I had to send you another one, but I also sent those as
I think the link we were using yesterday was from us self-registering rather than from the ones that were supposed to have been sent to us from the panelist
see,
ones.
you should have gotten an email. Now, again,
No,
I didn't do this.
I think we used the wrong link to try to join.
Okay.
And I think that was on us, not you.
Okay.
So
we've got a marketing person, marketing contractor that does some of our marketing for us, and she set it up. All right, I'm going to go on mute for a few minutes, and we'll come back in a moment. Thanks. All right. Well, good morning, everyone. My name is Mark Thomas. I'm the Executive Director for DMSC. If you didn't know, DMSC is the developer of the QIF standard. We're very pleased to have all of you here to be participating in our QIF Coffee Chat webinar series. And today we have got another session for you. Before we go to the actual session, let's, if you could go to slide 2, please. We want to go through a couple of housekeeping points here. All of you should be seeing on the right-hand side of your screen a GoToWebinar control panel. About 2/3 of the way down, you will see a line that says questions. You can click on there. And what we're going to do is that as you have questions, as we go through the session here today, type in your questions, and then when the session is over, we're going to have a question and answer session, and I'll be reading those questions as they come up and presenting them to our presenter. So that's number one. Number two, and you can do that at any time, but we're going to be covering the questions themselves at the end of the session. Second thing is that be aware that all of you as attendees will be getting a recorded video of this presentation. We invite you to share that with your colleagues, and hope you learn something through this webinar and the webinar series. So our presenter today is Thagu Vivek from Dimensional Control Systems, DCS, and we're going to let him run with it at this point. So thank you for coming, and I hope you everyone learns something from this session. Thank you. Vivek or Thagu, please go ahead.
Hello. Hello, everyone. Good afternoon, good morning, or good evening, depending upon where you are in the world. My name is Thagu Vivek. I'm the product manager at Dimensional Control Systems. We make quality control and variation simulation products for the quality industry. We have been involved in this industry for 20+ years, Six Sigma Black Belt, with a very heavy focus on implementing quality solutions across multiple global OEMs and getting to establish efficient systems within OEMs and suppliers on a global arena from the quality perspective. That's a quick note about me, but let's start with today's session. We're going to try to mix a little bit of QIF with QMS and then see where the overlaps are and what the challenges are. And as a company, we establish QMS systems within organizations, and we are now doing it under the umbrella of QIF on certain companies who have already onboarded under the QIF. So I wanted to kind of give you an overview of that particular component, where the challenges are and what the benefits of doing it with the integration of QIF with the QMS system. Just to step back a little bit, this probably everybody is familiar with it, but I'd like to just go through this just to identify the zone of which QIF components that we heavily work on. So QIF starts from the design per product. The document first embeds the MVD. From that, we determine the measurement requirements. Once the measurement requirements are done, those information is embedded into the QIF as resources and rules. Then follows the define and the measurement process, followed by, based off of that process, QIF plans. The document gets added with the information about the plans, and that's sent to the measurement devices or the inspection devices to execute the measurement process. Once the measurement process is executed, via DMS and different methodologies that's currently in practice, the outputs of that the results of that now flow into the QIF results components of the QIF, and that is where we come in, where we analyze and report the quality data. And once the analysis is completed, that information is stored back as QIF statistics, and the loop goes back to design and product as far as a closed loop control. So these are at 100,000 feet overview of the QIF. I just want to put this out here just to see from a QIF QMS zone where we primarily play in the sandbox of the later part of this QIF ecosystem. We start primarily, but we do touch upon all the other places because it is an integrated platform with QIF Plans, where what is sent to the measurement process, and primarily from the QIF Results perspective. Once we get the QIF results in the QIF document, we'll be able to take that information, use that for our analysis, reporting and dashboard, all those type of components that QMS provides, followed by exporting that into a QIF statistics information. So from a 100,000 feet and kind of focusing on the sections that we'd be touching on today would be primarily on the plans results part of it. When we look at quality data sources, when we walk into a shop floor or a company and then say establishing a QMS system, we see a variety of data sources for the shop on the shop floor. There are MES systems, there are MES systems which are integrated measurement systems, inline inspections, which are 100% inspection or inspection devices that are placed in line. There are near-line inspections, which are in the shop floor, but kind of a sample of parts are taken out for that inspection and then fed back into or put back into the line. And there is metrology labs. Parts are taken from the measurement from the shop floor into the metrology lab, where different devices and metrology equipments are used to measure the parts and then for check quality. There are also a lot of manual inspection stations that happen along in the shop floor, which are kind of attribute go no go, a lot of those type of information. Then we get sensors and PLC, where we collect a lot of attribute data. These all come under the umbrella of quality data, and of course we cannot ignore the supplier quality data, because there's a lot of data that pertains to quality that comes from suppliers. So when we walk into a company and look at the quality ecosystem, these are all the different components that we need to kind of encompass to create a full QMS system. Now, with all these variations, then we look at all the data variations within the for each one of them. Data can be held in a mode of databases. There could be data is usually automated. End of each measurement, the device spits out a file or stores a file in a network folder or provides a view to the user for part by part, and sometimes they are done in a batch. As a set of parts are measured, a data is results files or output to samples. So these are some of the batch processing. We see a lot of data variations on Excels and spreadsheets and ad hoc reporting formats. We also see streamed variable attribute data, which is time, space, or in a date time format with the attribute data attached to it with trace information. And there are external files that could come from different vendors and different suppliers. So when we look at variations of the data that's coming from all of these sources, there is a variety of variations that we need to tackle. Now, from the variations, each variation contains its own formats. The databases are not standardized. We had different database schemas. There are custom text formats from each device vendor. Every metrology software out there exports the file or the results file in a certain format that is custom to their solution. So there's a variety of those that we need to contend with. The stream namespace, there's different schemas that are applied to this. Excel and spreadsheets, as you know, it's totally open. It could be in any format. We need to cater to all those variations. And sometimes they are in a summary format. They are already put together in a summary format, and we have to take that information and decompose that into its measurement. So So these are all the different format variations. So you can imagine the permutation and combinations of this that we need to contend with when we walk into when we set up a QMS system, from the data source level, where they are coming from, the data variations that each one of these data sources, modes that they transmit the data, and from each mode, the different formats that they transmit the data. So challenge-wise, this has been a major challenge when we implement a QMS system. Management of our machine interfaces, management of file translators, and every time a translator changes, we have to, a format changes, we have to update the translators and things like that. Database schema changes sometimes need updates, and whenever we deal with manual data or any type of ad hoc data, those variations also need to be addressed. So you see the magnitude of homework and magnitude of the work that need to be done to bring the system under a QMS umbrella. But these are all eliminated if a company is onboarded onto the QIF. We primarily we ping off of the QIF results that's coming out of all these devices, whether it's an MES system, inline system, or labs or manual process. We also have to cater to sensors and non-attribute data, which is non-dimensional. So we do have a separate mechanism to deal with that. So that way, they're also brought under the QMS umbrella. But all the dimensional aspects of the dimensional measurements, we use the QIF results mechanism. And for the non-dimensional, we use the attribute and what we call a data grabber solution. And I'll kind of talk a little bit and show a little bit about that when we move into the demo part of it. So this kind of simplifies the entire QMS implementation from a customer perspective and from the implementation perspective, as far as the standardization. So when we talk about how we implement it, we primarily go and look for QIF results information that are embedded in the QIF documents that are provided by each vendor, and whether it's from MES, inline, lab, or manual, and that get fed into what we call our QMS system. We call that the QDM Gateway. We load the QM measurement plans based on the QIF plan information. So we have these two information that provides us the analysis capability of analysis, reporting, and dashboarding from the user perspective to have visibility of their quality data. Excuse me. So from a 100,000 feet overview, what are all the components from our excuse me, from our QMS perspective? Number one is the gateway, where we centralize everything because data is coming from different sources. There is user management, there is alert management, there are the plant and the hierarchy, the bill of materials management. All those components of a QMS system are integrated into what we call our QDM Gateway. And the first component that the main feeding component to that is the data that could come from different suppliers or different nodes from a supplier or different plans or different locations within a plant. We use a tool called Data Grabber that's been traditionally used from all up to before our QIF implementations, and now even with it as a mixture to handle all these different variations of data that's coming in, to collect all this inspection data, centralize them into our gateway. The next component that we have is the QDM 3D, which is a templates. So this is primarily, think of it like a QIF plans. It's equivalent to the QIF plans component, which stores the relevant information on how the quality engineers would like to view this data in a graphical format, or from a dashboarding and alerting perspective. So templates are created for the bill of material parts and stored in the gateway. Now, once those two components are there, now QDM Web allows a web-based access to, as a QMS system, web-based access to get any type of data from any device and view it with dashboarding and email alerts. So from a very high level, of a QMS system implementation, these are the very high level components. When we talk about gateway, it doesn't just do this. It does a lot more than what just a data processing system. Because when we talk about a company, the company has got hundreds and thousands of bill of material parts need to be arranged and collated and presented based on the hierarchy of a part, a product, a sub-assembly, a system, all the way to the individual part. So with that, the QDM Gateway allows, as one portal, it allows plants and suppliers to share data, quality engineers to create and monitor report requests, receive work orders. Here, sorry about that. Inspection departments to receive work orders and update the results. Data managers can log in and look and receive map and map report requests. Report publishers use a web-based real-time report publishing tool. Dashboards are for management or supervisors to look at the dashboards. Data analysis expert can perform root cause analysis. Product engineering can take this data and use it for robustness, and IT admin can use one centralized system to manage. So we talk a little bit about the product engineering part, is where the data that's going in because of the QIF, that gives a big leverage as far as closing the loop, as far as with the MBD integrated into it. We can close the loop back to product engineering with the onboarding into the QIF platform. So from a gateway perspective, it's a web-based portal to do everything from all different stakeholders of quality within an organization, whether you are a shop floor operator all the way to the upper level corporate management. So initially, let's look at QIF, QMS workflow, QIF plans, and QIF plan provides a graphical measurement plan. This is what we call a template. This is one of the requirements to kind of convert a plan into a graphical measurement plan from our perspective, so that it can use that as a graphical template. So let me maybe quickly escape out of here, and let's kind of go through. Let's look at a plan. Oh, sorry. So plans are basically we set this up with the CAD part, and the data that came from the QIF plans is the ability to kind of provide a visual context for a web-based user who is not on a CAD platform, who not integrated into a CAD platform, and to be able to view any type of data, whether it's dimensional, non-dimensional attribute, or any type of data. So so a plan primarily consists of what we call an index page on all the locations of the measurement, followed by n number of graph pages, which basically have placeholders for the data when the results are in place. So plans are basically blank reports. When the parts are measured, the plans can be or populated with data. So this is from the plan perspective. And once we have the QIF results, so now I will open the. So when we load in the QIF data, so now the plan is converted into what we call a report with statistics, with color-coded boxes telling whether it passed or failed for that particular measurement or GD&T, and followed by n number of graph pages, which are all point and click, drag and drop, easy to visualize the data from a part perspective with all the statistics calculated and color-coded statistics with for the entire part. So when you look at the plan and the part, so now these are the components that are primarily setting up from a setup perspective. Now we're going to go into the web part where the QMS system itself, the gateway, to see how these are so I'm going to log into our gateway, how these components are used from a quality engineering perspective. So I'm logging into the QDM web. Gateway. So this, as we looked at the centralizing of all the data, and we just looked at one QIF plan and report for one part, but this could be for hundreds of parts, and for entire bill of materials, this is set up in the gateway. So a user can navigate to a company, which is the highest level, to a product type, a plant that's making the part, the product type, the program that it belongs to, the subsystem, and the inspection program that this particular inspect, so the results for a certain inspection. So the system now looks in the database and brings up all the information that belongs to that part number, whether it's the QIF document, the auto-published reports, or any type of measurement plan, or anything that's associated to it as documents. Every measurement that was measured for the part, there are 7,389 measurements, parts that are measured under the base. And a quick summary of how that particular part is performing based on the number of characteristics at 95.22%, and the ability for the engineer to quickly take, let's say I would like to see the last 30 parts, select the data, and generate a report for this component. So in real time, what it's doing is it's taking the data from the plant or supplier, wherever the data is coming from the QIF results that's loaded into the system, and adding that to a template that we saw in the previous the measurement plan and the reporting templates, and it's creating a new report based on merging the template and the data and creating a fresh report for the last 30 parts. So now we have the report for the last 30 parts with statistics for that particular part number from the quality engineering perspective, and to drill down and look at one of these parts in a detailed level, we can click on that, and it would take me to a detailed view of one of the features. If there is a feature that you wanted to look at in detail, then the system generates a Six Sigma type of report for that particular feature, and as a which includes pattern analysis with Western Electric rules, the run chart, the histogram, and the trend charts with all the statistics calculated. And if we wanted to have more trace information, when we click on that feature, it tells me it belonged to that particular part number that was measured on that date and time. All these information came from the was loaded from the QIF results when the part was measured and uploaded. The QIF results file was uploaded into the system, but the information is presented using this QDM gateway based on the workflow of the quality process within the company. So now we're looking at it from a single part perspective, but when we look at it from a company perspective, I'm going to start with a dashboard. From this particular gateway houses the information for everything that particular company makes across the globe. The company is M Electric. They make 2 product types, wiper motors and cables. They make them in 1 assembly plant and a stamping plant and 2 primary suppliers. And these are the primary programs that are currently in production. So each one of these could have hundreds of parts under them with a hierarchy of bill of materials. So if we want to kind of drill down and look at it at a high level, so I'm looking at it from an overall wiper motor perspective. It is running at 97.02% in spec for all the features that are measured from the plants, the stamping plant, the suppliers, the assembly plant that belong to this particular wiper motor program. And it breaks it down to individual data sources, whether it's how is the stamping plant contributing to the quality metrics of this wiper motor? How is the supplier contributing to the quality metrics of this program? So it kind of breaks down and runs a report for that. We can also look at trends of how the trends are operating, so that you can see if there's a trend variation on a cumulative basis of all the parts. Now we're not looking at single part here. We're looking at all the parts that are made at the assembly plant for this particular program is what this cumulative dashboard report is showing. So maybe we will start with the supplier, and we'll look at it at a part level. This supplier is making 3 components for this particular wiper motor, and let's say I'd like to look at the base, and now it takes me to the navigation screen for that particular base. So data for this came from, there are QIF documents that are associated to it. So let me click on one of the QIF document, and so this is the QIF document that contained that information, or whenever we loaded that information into the system. So we have a link to the document as a part of the inspection itself that can be referenced for any future purpose. And this, from here on, we looked at it in the previous example of how somebody can quickly look at the last 10 part report that's automatically available for it's always running a last N part report as parts are measured, and email alerts and text alerts are sent to quality engineers who are monitoring this particular part number, so they can be alerted if one of these part numbers are going out of control, and they can take corrective actions efficiently. So the system is a fully automated system from the QDM, from the overall QMS perspective, whether looking at it holistically from the dashboard perspective or looking at it from a part by part data. But either way, the data is always collected part by part or sub-assembly or assembly, wherever the metrology is happening. But the system, based on the hierarchy, has the ability to roll them up and provide necessary quality metrics to the different stakeholders. So let me go back to my PowerPoint here. So with this, from a QMS perspective, we're looking at data sources, data variations, and how QIF can handle that. Since we have a little bit more time, I would like to go back to the QDM Gateway for a minute and talk about the different mechanisms that we could load data from. So typically, data pools are set up to load data from certain locations. So as parts are measured from different components or different within your network, the result files are stored in there. Let's say an inspection is run and a QIF results document is updated. we have the ability to monitor that, update, and go and load that data into the system. So those are some of the automations that can be done in the back end, that manually data doesn't have to be pushed. System can monitor for data updates and automatically pull that information into the system. With that, let me go back to my PowerPoint. So this is at a very high level how we utilize how we use QIF results and as a system standardize on the or how we apply that in a QMS platform. From a challenges perspective, like we said, the components that we are going to, when we look at QMS, there are going to be data which are dimensional and non-dimensional. So especially when we look at manual data, which is coming from spreadsheets, and sensor data that is coming from data streams, primarily they are non-dimensional. They are not under the QIF umbrella at this time, but this is something that could be incorporated. But the QMS system kind of incorporates both, because any company typically will have a mix of dimensional and non-dimensional measurements from a quality perspective for the overall quality of the program or the part. This could be, paint thickness, pressures, temperatures, torque values, all those type of data also attribute to the quality of the product. So the QDM kind of, the QMS system provides a mix of wherever we have QIF available, we can load that information. But wherever we don't have the QIF information available, and this could be evolving an evolution as more and more, maybe in a company right now only the CMM rooms are capable of QIF results. The MES and inline systems are still running in a file-based mode. We can still set up the system efficiently, and as these inline and MES system and manual machines or vendors are onboarding into QIF and being able to QIF documents and results and onboard into the QIF stream, we can include them into the QMS umbrella. Until that time, we can use the current methodology that they are using, file-based or stream-based or whatever our database methods that they are currently utilizing. So, so this allows for a gradual onboarding into a QIF corporation base, where depending upon catering to and having a system that can accommodate legacy systems plus new technology systems, which is very typical in any organization, because every company's got a lot of legacy systems that they cannot replace in a short notice. So we need to have a system that can kind of mix and work with QIF and legacy protocols of data. So primarily, this is kind of how we've been proposing our solution to companies when we come to implementing QMS systems. And I think I'm a little bit fast today, and I kind of I think we're pretty much at the end here. So I would like to open it up for Q&A, or I think there is also a poll in the
Hey, Thagu.
yes.
I'm sorry. Can you so for the QIF with the identifiers, how does that feeding the measurement plan help with feedback loops?
Yeah, once the QIF document, so the QIF plans and results, everything is embedded based on the unique IDs. So as we have the results with the unique IDs, they get the thread is maintained in the QIF document that they could go and relate to the QIF plans, and that could automatically go upstream to rules, resources, and MBD. Everything is based off of unique IDs.
Does this help with MBD and feeding back into other systems like PM or
We
CAD?
primarily, from the QDM perspective, we primarily we are at the we're on the downstream end where we consume the results and provide analysis reports and dashboarding capabilities to the users. At the upstream end, our 3DCS product has those links to touch between MBDs and resources and rules. Maybe that's another webinar.
Right. So the 3D CAD, when it connects to the QIF data, could you go over a summary if you're familiar with how the 3D CAD data would connect to the QIF data? So from what I understand, the 3D CAD, when you do put it into a QIF container, it's going to give unique IDs to all of your components and your information, right?
Yes. They're attached to surfaces and different entities within the CAD.
Yeah, so if you want to then compare the 3D and the results, you'd want to pull the results back into CAD then in order to do a 3D comparison, right?
No, yeah, you're partially correct, but that part is what's done by the measurement process. So the measurement process is the one that takes the information from the CAD. This is done by the metrology devices. So Metrolog measures this part and provides. So in our case, in our example today, Metrology provided the QIF document after measuring the base of the part. So the QIF results are based off of loading in the QIF plans, creating a measurement process, a measurement routine from DMS that was generated, and running the DMS and creating QIF results. So that part is done primarily by the QDM, by the measurement metrology devices. We only consume the results.
And if you wanted to then compare those results to the CAD, the 3D CAD, will we do that using a QMS system, or we want to put that back into the CAD system and use a feedback loop?
No, when we say results, the results mean it's already compared to the CAD, which is a nominal, and the results meaning the deviation from the nominal is what we report. So when we talk about the term results mean it's already compared to a nominal, and the information is fed to us, and that part is done from the measurement process. So when we talk about the results, let's say a diameter, the deviation of the diameter of is what we are reporting. But from our analysis perspective, we're not reporting the one part deviation. Hundreds of those parts are measured, and how is the center of the whole varying, or whether it's trending out or trending in is what we report on from a QMS perspective in that area of QMS. From the metrology area is where we compare the actual to the measured to the nominal and generate these results.
So
okay.
Here's another good topic. Thank you, Vikram. In general, having an inspection plan is challenging when there are several design variations and less quantity per design. I'm guessing measurement points. Can we use data for analysis with any specific inspection plan? So if I've got different inspection plans, is there a way to still correlate that data?
From one part to another, or within the same part?
I believe for data analysis. So if I've got multiple inspection plans in the same part, would I be able to still, I believe, can use data for analysis with any specific inspection plan?
The results are basically an outcome of the plan. So plans are basically telling what needs to be measured, what is critical to quality, identifying what's critical to quality, and creating a measurement plan for the metrology devices to measure those. And once the metrology devices measure those points or features based off of the QIF information, then So there is a direct correlation between plans and the results, and results can be applied to the plans to fill in the empty. So like when I showed you the two components of the QDM, so this is the results, which is basically the measured values for each one of these measurements that was in the plan, and the plan would have just been an empty document of this.
So here he clarified a little bit. I just so if you don't have a specific inspection plan, where would you start? Is it would you then take maybe the CAD model with CAD points, or would you use a simulation result, or would you use maybe GD&T? Where would you get if you have QIF, say a CAD model in a QIF container there, since we are referencing MBD, and you didn't have a specific inspection plan, is there a way you could still get some results on your parts?
Yeah. So then it's primarily up to the metrology device, which loads that CAD part, and they come up with a DMS program or an inspection program on what they deem critical to the quality and measure those points, and that's what's fed to us. So from a QMS perspective, we don't get into that.
All right, here's a great question from Sumit. Does the QDM database, as we're using as our example QMS system here, interface with a PDM or a PLM system? So can you use a PLM system as an input or output to it?
Yeah. So from the QDM gateway part, the workflow, a PLM system workflow can be integrated into the QDM web gateway. So basically, the bill of materials that you have in the PLM system is exactly can be. I'm just waiting for this to update here in a minute. Okay. Yeah, the bill of materials from the PLM system can be applied to exactly the QDM web gateway, and if both follow the same hierarchy as of the bill of materials and part numbers, then we can kind of go back and forth between a PLM system and QDM gateway to get the corresponding measurements for a part that's referred in the PLM system. Yes.
Are the results correlated with CAD data in PDM? PDM.
Product data management.
Oh, product data management. Yeah. Okay.
So the results correlating with let me kind of use this as an example. So the results for these measurements, let's take this as an example. These are measured against a CAD part, and the deviations are provided to us as the results for the last 10 parts of this particular part number. And that's what we are creating trending in SPC and all the characteristics from the process correction and process improvement and quality improvement perspective. So the results are already correlated or tested against the CAD nominal to provide these deviations, and that's what we use. So the answer is yes, they are correlated to the CAD by the measurement device.
And with QIF, using the identifiers, you should be able to correlate it back into your CAD. So using the as-built in your CAD model for simulation and design improvements or testing solutions, we actually have a couple of customers we've worked with that have interconnected their QMS and their CAD systems, so that way they can use the the CAD system to create measurement plans to feed the quality management system, and then use a feedback loop to bring the measurement data back into the CAD for simulation or for testing build issues and finding the root cause. So there are both specific and non-specific feedback loops you can use for that, depending on what kind of environment you have set up. A lot of QMS systems can output the measurement data based on the point coordinates so that you can utilize those in your CAD system. Ours also has some specific connections to our CAD integrated app, 3DCS, that makes it a very streamlined process to get that data back into your CAD model for analysis. So depending on what your environment is, you know, you don't necessarily have to be using the products that we have, but we do set as a value add and see value in that. So we have provided some tools to make that a lot easier.
Yes, Ben, to extend on that, think of the QMS system that you see here as a repository for all your measurements in a very streamlined cataloged method. So now that the data is available, if you want to take the some measurements from the shop floor and feed it back into the upstream to the design, we have tools here to export this data into to feed to Excel or whatever format that the upstream systems can take in, or as you could download the QIF document and use the QIF document to use it upstream. So multiple ways to take that data back to close the loop. Yes.
Okay. Let's take a quick breather for a second. I want to send out a poll. It's pretty simple. We're just curious on whether you have an SPC platform as part of your QMS and how often you use it. A lot of our clients we talk to and a lot of industry companies in industry we talk to are at different places when it comes to using SPC and automating their measurement plan authoring and data collection, and just curious to see if we can get a poll that we'll of course share with everybody here, so you guys can see where the audience is at. Not having a system is perfectly all right in the sense that you know, a lot of companies are still using Excel sheets or still doing it by hand. This method does work. It's just that there are a lot of value and a lot of time savings and a lot of error proofing you can do by automating it, depending on where you're at in your quality process or quality system updates. That the digital transformation oftentimes is referencing this automation and change from, you know, using hand systems, hand charts, hand spreadsheets, piles and stacks of Excel sheets, and moving into something that's a little more standardized and where you can have a single source for your quality. And there are a lot of different platforms in the market. We're one of them, but there are of course other similar systems. All right, I'm just going to give it 10 more seconds. There we go. All right, I'm going to close the poll, share it with everybody. So what we see here, three groups with the two largest groups, the very largest being that you don't have a system or platform at this time. There are a lot of cloud-based platforms that are very inexpensive and easy to roll out. I highly recommend, if you don't have a platform, taking a look at one of those, or comparing a couple, obviously is the best solution, to see which works best for your environment, as a means to get some automation in there. You can find it can be a huge time savings and save you a lot of headaches, especially if something goes wrong, right? If something goes wrong and you've got all these Excel sheets to hunt through and figure out, as opposed to having a system where you can just pick a time, pick a machine, pick a part, and get some reports that can give you answers right away. So having an SPC platform is just really helpful to have, even at a base level. And those of you, the 20% that do have one, I can see that you're using it daily and already seeing the benefits of it. QIF just gives you a nice way to streamline some of these data collections and data outputs and help with some of the standardization across that. Speaking again, Thagu, can you help, as we're closing up pretty soon, can you help summarize kind of the benefits here of connecting QIF with your quality system?
Yeah, primarily as we looked at the idea of streamlining the data from with traceability. So QIF provides the traceability all the way from the design to the measurements, to the measurement plan, to the results, to the statistics. So that traceability is what we as a QMS system implementers and designers, we have major challenges with. And QIF kind of streamlines that entire process into one efficient process. So I think onboarding onto QIF, if you have, will give you the benefits, not only the ease of implementation and the speed of implementation, but provides you the connectivity between all the way from design to engineering to shop floor. And I think that is that's becoming more and more critical as we move forward with the Industry 4.0 type of organizations, which is about digital transformation.
This is actually more of a quality management question, as I got to pass this over to Mark pretty soon. In fact, this is probably going to be our last question. I know Mark wants to talk about the next event that DMSC is doing. So if you've got a data set in CSV, and you wanted to start having an additional feature added to that data set, so say you've got coordinates that are associated with cavities in a molding inspection, and you wanted to number those cavities, what would be some good ways, say before or with your QMS system, that you could add those features to those data sets?
There are user interfaces that can do it, or a quick and dirty way would be to just create an Excel sheet of those cavity numbers and just load that cavity numbers with the data into the system, and the system creates its own mapping for that. Or if you just want to add one or two ad hoc or edit them, the user interface within the QDM web portal allows you to do it. But if you got a quick way to do it, just create a spreadsheet with that numbers, cavity numbers, load them as a nominal file. It registers them and creates a bin for each one of those for adding measurements downstream.
All right. Okay. So at this time, I want to see if we can go back to the PowerPoint, Thagu, and go to the last page.
PowerPoint.
Thank you, Mark. I appreciate you having us on. So this is Ben Reese. I'm with DCS. I'm in the marketing side of things, and I'm a colleague of Thagu's, just on here to help out a little bit. So thank you very much for having Thagu and I on today, and for letting us speak with your audience. I appreciate it very much.
Thank you. Thanks, Mark. Thanks for everyone who joined.
Yeah, we certainly appreciate it. Again, that was Ben Reese from DCS that was doing the moderating for the questions. And of course, Thagu, thank you very much for the presentation. We can see that from the poll, there's quite a few people who are not using quality management systems today. And certainly there's many, many benefits that hopefully they know more than when they started today. So thank you both. I just want to promote our next upcoming coffee chat, which is next month. And although the subject matter looks to be fairly elementary, QIF 101, my guess is that you would probably, all of you, learn something new. So I highly encourage you to sign up for the next session. It's QIF 101, Understanding QIF Basics. And just as important, I'm sure there are other people in your organization that may not be as knowledgeable about QIF, but in order to get them as excited about QIF as you are, this will be a very good session to introduce QIF to people who in your organization who may be less knowledgeable. So we encourage you to come on for our next session, which will be next month. And we certainly appreciate you joining us today. And again, we appreciate the guys from DCS to making the presentations today. Don't forget, tomorrow you will receive a recorded version of this video. Keep in mind, it won't come until after 12 o'clock. So it comes basically 24 hours after this session ends. So anyway, we look forward to having you join us next month. And thank you for joining us today. And I'm sure the guys from DCS feel the same. So thank you very much, everyone.
Thanks. Thanks, everyone.
Bye now.
Bye.